So here's what you should understand at this point about acceleration. Remember a definition. Remember a word definition, and also remember the mathematical definition of acceleration. Remember that acceleration is the rate at which velocity changes, and we say that mathematically as acceleration is equal to change in velocity divided by change in time, or acceleration equals the final velocity v sub f minus the initial or beginning velocity v sub I divided by time. If you look at this equation, you can easily see that the most important part of an acceleration is the change in velocity. So right now we're going to take a few minutes, or we're going to talk about how changes in velocity affect the acceleration of any object. When that velocity changes, how does that cause acceleration to take place? Well, let's take a look at an actual example of a velocity. Here's an example of a velocity. Let's say a velocity of 30 meters per second east. You can easily see that this velocity has two parts. It has a direction and it also has a speed component. Two parts, and both parts are important because acceleration takes place when any one of three things happens: when an object speeds up, when it slows down, or when it changes direction. And that is what you want to remember. Remember that when acceleration takes place, an object is going to speed up, slow down, or change direction. Any of those three things happen, acceleration is taking place. So if a car, like the race car, is speeding up, you know it's accelerating. If the driver puts the brake on and slows down, then you know that there is an acceleration taking place because the velocity is changing. If the object turns a corner, then you know that acceleration is taking place because the direction is changing. That's what acceleration is. That's how changes in velocity affect the acceleration of an object, and that's what you want to remember. So here's what we now understand. When an object accelerates, it speeds up, slows down, or changes direction. But now let's take a look at how this affects objects in the real world, such as a car traveling down a road. The diagram that you see here shows a car traveling down a road going around a curve. You'll notice that this is an aerial view. An aerial view is simply a view that looks down from above, as though you're looking at the surface of the earth in map view or from an airplane. And really what you're doing here is you're looking at the top of the car, and you can see the car right here traveling down a road, traveling north. And if the driver at point A in this car looks at his speedometer, he can see that the speed of the car is 25 kilometers per hour. A speedometer measures speed. It doesn't measure velocity, because if we look at the velocity of the car at point A traveling down the road, the velocity has both a speed and a direction. Remember, velocity is a vector. So the velocity is 25 kilometers per hour north, and we know it's north because over here it says north is towards the top of the page. So the velocity here is 25 kilometers per hour north, but the speed is just 25 kilometers per hour. If we come up here to point B and look at this car again, the driver looks at his speedometer and he can see that the speed hasn't changed. The speed is constant. The speed is still 25 kilometers per hour. But the velocity has changed. The velocity is now 25 kilometers per hour northeast. The car is now traveling in a direction of northeast, going around the curve. The speed is constant. The velocity is what's changing. At point C, you can see the car. Now the speed, if the driver looks at the speedometer, is still 25 kilometers per hour. The speed never changed. All the way around the curve, the speed was constant, unchanging. But the velocity is now 25 kilometers per hour east. So the direction changed, and that changed the velocity. Because remember, a velocity has two components. It has a speed, and it also has a direction, because it is a vector quantity. How do changes in velocity affect the acceleration of an object in the real world? As the car traveling around this curve shows you, speed can be constant and unchanging, while velocity can change at the same time, meaning that the car or any object can accelerate while speed remains constant. Remember, acceleration takes place when an object speeds up, slows down, or, as you see here, changes direction.